The operating system is most visible part of the operating system. It provides the mechanism for storage of online data and access to both data and programs of the operating system and all the users who are using the computer system. The file system consists of two distinct parts. Number one, a collection of your files which storing related data. Number two, the directory structure which organizes and provides information about all the files in the system. We see that various aspects of files and the major directory structures, and later we'll study and we'll discuss the way to handle file protection necessary when we have multiple users and we want to control who may access files and how files may be accessed. The computers can store information on various storage media such as magnetic disks or magnetic tapes, optical disks, so that the computer system will be convenient to use the operating system, and the operating system provides a uniform logical view of information storage. The operating system abstracts from the physical properties of its storage devices to define a logical storage unit, that is, the file. The files are mapped by the operating system onto physical devices. These storage devices are usually non-volatile, so the contents are permanent even the power failures and system reboots. A file is a named collection of related information that is recorded on a secondary storage. A file is a collection of related information that is recorded on secondary storage. From a user's point of view, a file is the smallest allotment of logical secondary storage. That is, data cannot be written to secondary storage unless they are within a file. We cannot directly write data onto the secondary storage. Only through the file we can store the data into the secondary storage. File represent programs, both it may be source code or object forms, and data. Data files may be numeric, alphanumeric, or binary. Files may be free form such as text files or may be formatted rigidly. In general, a file is a sequence of bits, bytes, lines, or records. The meaning of which is defined by the files is the meaning of a file is defined by the file's creator and user. The concept of file is that extremely what we discussed is in general. The information in the file is defined by its own creator. Suppose we create a file, it's depend on the creator. Which information it is holding. Many different types of information may be stored in a file. That is, a source program may be stored, an object programs may be stored, an executable programs may be stored in a file, a numeric data, a text, and any records like payroll, employee payroll records can be stored, and graphic images, sound recordings, and so on. All these data can be stored in a particular file. The file has a certain defined structure which depend on its type. Suppose A text file is a sequence of characters organized into lines, and it possibly like pages. A source file is a sequence of subroutines and functions, each of which is further organized as declaration followed by executable statements. Suppose let us see what is an object file. Object file is a sequence of bytes organized into blocks understandable by the system linker. An executable file is a series of code sections that the loader can bring into memory and execute. As we discussed in the previous slide, a file have a sequence of words or bytes. It's a simple record structure. If a text file, it is lines, and it is fixed length and variable length. It file structure, sometimes a complex structure, a formatted document, and relocatable load file. And who decides whether operating system or user? User writes the program. Now we discuss about file attributes. A file is named for the convenience of its human users and is referred to by its name. A name is usually a string of characters such as, for example, example.c. Some systems differentiate between uppercase and lowercase characters in names, where other systems may not differentiate. When a file is named, it becomes independent of the process, the user, and even the system that created it. For instance, one user might create a file example.c and another user might edit that file by specifying its name. The file's owner might write the file to a floppy disk, send it to an email, or copy in a network, and still it is called as example.c at the destination system. File attributes vary from operating system to another, one operating system to another, but typically consists of all these things that are: first one is name. The symbolic file name is the only information kept in human readable form. Identifier. This unique tag, usually a number, identifies the file within the file system. It is the non-human readable name of the file. Next one, type. This information is needed for systems that support different types of files. Location. This information is a pointer to a device and to the location of the file on that device, where this file is located in the device. Size. The current size of the file in bytes, words, or blocks, and possibly the maximum allowed size are included in this attribute. Protection. Access control information determines who can do reading, writing, or executing, and so on. Time, date, and user identification. This information may be kept for creation, last modification, and last use. These data can be useful for protection, security, and uses of monitoring. The information about files are kept in the directory structure, which is maintained on the secondary storage. Now we'll discuss about file operations. A file is an abstract data type. To define a file properly, we need to consider the operations that can be performed on files. The operating system can provide system calls to create, write, read, reposition, delete, and truncate files. Let us examine what the operating system must do to perform each of these 6 basic file operations. It should be easy to see how other or similar operations such as renaming a file, can be appending a file, can be implemented. Creating a file. 2 steps are necessary to create a file. The first one, space in the file system must be found for the file. We discuss how to allocate space for the file in the next session. Second, an entry for the new file must be made in the directory. After creating a file, it should be found in the directory. Second, writing a file. To write a file, we make a system call specifying both the name of the file and the information to be written to the file. What the information we want to write to the file. Given the name of the file, the system searches the directory to find the file's location, where this file is located in the directory. The system must keep a write pointer, WRIT, write pointer to the location in the file where the next write is to take place, from where we want to write. The write pointer must be updated whenever a write occurs. Next we will discuss about reading a file. To read from a file, we use a generally system call that specifies the name of the file and where in memory the next block of the file should be put. Again, the directory is searched for the associated entry and the system needs to keep a read pointer to the location in the file where the next read is to be taken place. Once the read has taken place, the read pointer is updated. Because a process is usually either reading from or writing to a file, the current operation location can be kept as a pre-process, kept as a per process current file position pointer. This is most important, current file position pointer. Both the read and write operations use the same pointer, that is current file position pointer. Next we will see the repositioning within a file. Within a file we can move the data, repositioning. Okay, how we can achieve, let us discuss. The directory is searched for the appropriate entry, and the current file position pointer is repositioned to a given value. Whatever the value we give, as per the value it is repositioned. Repositioning within a file need not involve any actual input-output operations. It's purely within the file. This file operation is also known as a file seek, S-E-E-K, seek. Next, we'll discuss about deleting a file. Even to delete a file, we search the directory for the named file. If having found that associated directory entry, we release all file space. We are going to release all file space so that it can be reused by other files and erase the directory entry. Now let us see truncating a file. The user may want to erase the content of the file but keeps its attributes. Attributes will not be deleted. Only content in that particular file will be deleted. Rather than forcing the user to delete the file and then recreate it, this function allows all the attributes to remain unchanged except for file length, but lets the file be reset to the length 0. Since content is not there, the length will be reset to 0 and its file space is released so that others can use it. Apart from these 6 basic operations, there are few more common operations are included. That is appending new information at the end of an existing file. We can add new data to the existing file and renaming an existing file. These primitive operations can be combined to perform other file operations. For instance, we can create a copy of a file from one place to the other place, or copy the file to another I/O device such as a printer or a display. By creating a new file and then reading from the old and writing to the new file. We also want to have operations that allow a users to get and set the various attributes of a file. We may want to change or we want to know the author of the file, the length of the file. These are all file attributes. Next important thing is we need to discuss about there are two system calls associated with file operations. One is open system call, second one is close system call. We'll discuss about open system call in detail. Most of the operating systems involve searching the directory for the entry associated with the name file. Whatever the name we'll give, that will be searched in the directory. To avoid this constant searching, always we need to search the directory. To avoid this constant searching, many systems require that an open system call be made before the file is first used actively. Before any file to be used actively, this open system call should run. And every operating system keeps a small table called open file table containing information about all open files. all whatever the, suppose the process may open 2-3 files. So how many files are opened? The 3 files are opened with its name, its attributes should maintain in the open file table. When a find operation is requested, the file is specified via an index into this table. So in open, the file is open means it should be available in open file table, so that no searching is required. When the file is no longer actively used, process may not want this file and it is closed by the process using close system call, and the operating system removes its entry from the open file table. Okay, this is the open and close system calls in file operation.